Hey everyone, I'd like to kick off this channel with a Back to Basics series featuring the humble Arduino Uno. My plan is to share with you many of the things that I've learned over the last 10 years working with Arduino and microcontrollers in general. As I started my journey into hobby electronics with the amazing Arduino Uno, I'd like to help you do the same. In this series, we'll build a foundation that will help us build and create amazing projects. And the Arduino platform will help simplify a process that can sometimes be a little overwhelming. So what is an Arduino anyway? The Arduino platform is a combination of hardware, the development board, software, the integrated development environment, or IDE, and code, the Arduino core, which are pre-built C functions that simplify using many features or peripherals found on the embedded microcontroller. We'll take a closer look at each of these three things in more detail in a minute. So the next question you might have is, what can we do with an Arduino? As an example, say you want to design a device that indicates how far away an object is. Well, we can measure the distance with an ultrasonic sensor and provide that information as an input to an Arduino board. Then we program the Arduino to determine what to do at a specific measurement. Finally, the Arduino can turn on LEDs to indicate how far or close the object is. The key takeaway is that the embedded microcontroller is really good at taking in inputs, applying logic, and providing outputs. Let's take a closer look at the hardware. Honestly, this could be the most overwhelming part in the beginning. The company that designs and manufactures Arduino boards have a lot. Let me repeat that. A lot of different boards to choose from. Beyond the officially branded Arduino boards, there are even more Arduino compatible boards available on the market. The great news is, it doesn't really matter what board you start with. The power and usefulness of Arduino is that the same development environment and code will pretty much work the same on any of the development boards. So if you start a project with the Arduino Uno and find later that your project needs more flash memory or a faster processor, most if not all of the code you have written for the Uno will work on any of the other Arduino or compatible boards. In this series, we'll start with the Arduino Uno, as it provides a lot of functionality and demonstrates what the Arduino platform can do. You'll see me use both officially branded Arduino boards and unofficial Arduino compatible boards throughout this series. We'll also be using a number of supporting electronic components such as jumper wires, breadboards, resistors, capacitors, etc. I'll put links down in the description where you can purchase all the hardware needed to follow along. What makes the Arduino board special is it includes most of the hardware we need for getting started already built in. The microcontroller embedded on the Arduino Uno is an 8-bit AVR-based Atmega 328P running at a blazing fast 16 MHz. There's a built-in programming and communications interface where you can supply USB power and program the board. There's a 7 to 12 volt DC power input jack with voltage regulation to ensure the correct voltage is supplied to the microcontroller. The board includes breakout pin headers which allow for easy access to I/O pins. There's also an in-circuit programming header for when you want to use an external programmer, which we'll cover later in the series. And finally, there's a convenient reset button and indicator lights that can give us some indications of what is happening on the board. Having all these features integrated onto a single board makes getting started much easier and faster. If we did not have a board like this, we would need to prototype out all of these features on a breadboard, which results in a much less user-friendly configuration. Now for software, there are quite a few options for writing code and programming the board. Some people find a simple text editor and command line interface is sufficient to meet their needs, while others might want the bells and whistles of a full-fledged IDE such as Microchip Studio. The most common option, and somewhere in the middle of the two, is the Arduino IDE. This is a Java-based application that is tailor-made to support programming and uploading code to the many Arduino and compatible boards. The Arduino IDE is open source and free to download via the Arduino website. To download, visit www.arduino.cc and select Software from the main navigation menu. Next, select the Download option, which opens the download page. Here you can select the latest version of software that's compatible with your computer. After clicking on the download link, there's usually a page asking you to support the project. Here you can either contribute and download or just download the software. Once you have the installation file downloaded, you can install and run the application. To me, the Arduino IDE strikes a good balance of features, allowing me to do everything that I need without being overwhelmed with so many features it's hard to know what to do next. Now that we have the IDE installed, let's talk a little more about the Arduino core. This is what really sets the Arduino platform apart from many other microcontroller development boards. By using simple functions, we gain access to and can manipulate the peripherals found in the embedded microcontroller. Without the layer of abstraction that Arduino core provides, we would have to dig through the data sheets to find what internal registers were responsible for controlling the features we want, and then use bitwise manipulation to configure the microcontroller for use. We can use a simple programming function like digital write, where we can identify the pin we want to use and whether it's high or low. And because the programming function is agnostic of the hardware it's running on, the same function works on all the boards previously mentioned. To better illustrate how much simpler the Arduino core makes programming for us, here's some example code for writing a string to the serial interface, or UART. On the left, you see what it takes to configure and use the Atmega 328P microcontroller with no layer of abstraction. And on the right is the code utilizing the Arduino core on the same Atmega 328P chip. Even without knowing what all the code represents, you can see that the Arduino core is doing a lot of the nitty-gritty stuff for us behind the scenes. So we can focus on our project and not what register needs to be manipulated. In some cases, this layer of abstraction can come at a performance cost, and not all the features of the embedded microcontroller are made available through the Arduino core. But we can learn how to overcome these things in the future. But for right now, there's nothing stopping us from creating awesome projects. In our next video, we'll learn how to control digital outputs to flash an LED on and off. Until then, thanks for watching.